Okay, so covalent bond is formed between non-metals. So these bonds that are formed between the non-metal atoms, there are sharing between these two atoms, but some covalent molecules contains more than two atoms. Okay, so sharing of electrons with each other will cause each of the atom to obtain stable noble gas configuration. So these, I will give you some examples. Okay, in this video, I will be drawing a few dot and cross diagrams to illustrate covalent bonding. Okay, the first one, hydrogen. Hydrogen gas has a formula of H2. Chlorine gas or chlorine molecule with the formula of Cl2. Also, other group 7 molecules can be drawn similar to chlorine. What we do is just replace symbol to Br for bromine. Oxygen gas with a formula of O2. Nitrogen gas with a formula of N2, as well as carbon dioxide. Similar drawing for another compound CS2. H2O water. Similar drawing for H2S because oxygen and sulfur, they are both in the same group. Organic compounds like CH4, which is methane. Organic compounds like CCl4, which have a similar drawing to CH4. Right, so if you are quite confident in drawing covalent molecules, you can pause the video here, take a look at this question, draw a dot and cross diagram to show the electronic structure of hydrogen, showing only the valence electrons. So you can pause, do your drawing. Once you're confident of your answer and want to check your answer, play the video again. Okay, so I will be explaining how to do this question. Okay, so from periodic table, check hydrogen. From the periodic table, I have retrieved this number. H is 1, so 1 electron only. So hydrogen has a formula H2, so there's 2 atoms. So I'll explain a little bit later how I get the sharing inside this. So once share 1 electron each, this hydrogen now has 2 electrons in the valence shell. Okay, this is the same for this hydrogen with also 2 electrons in the valence shell. So working wise, usually I'll do, you will need 1 electron to reach a duplet configuration, which is the maximum number of electrons in the first shell, 2 electrons. Okay, as a habit, draw in the legend. Cross for electron of first hydrogen atom, dot for electron of second hydrogen atom. Next question, we have draw a dot and cross diagram to show the electronic structure of chlorine, Cl2. Show only the valence electrons. You can pause and practice and play the video again when you're ready to check your answer. Now, let's check your answer. Chlorine formula needs to be memorized, Cl2. With a 17 electrons, the configuration is 287 for both atoms. So it needs 1 electron to reach the octet configuration of 288. Same for the other chlorine atom. So I have 2 atoms symmetrically drawn. If it needs 1 electron, it will share 1 electron too. So I will fill it in the middle where it's sharing. So 7 valence electrons and 1 electron is used in sharing. This leaves us with 7 minus 1, which is 6 electrons, to be drawn in the outermost shell, or called as a valence shell. So I'm drawing 6 to each of the chlorine. So the legend as follows. Once again, another question. This time, the question is draw a dot and cross diagram to show the electronic structure of bromine, Br2. Show only the valence electrons. Now, bromine is not the first 20 atoms in the periodic table. You will not be able to write out the electronic configuration for this question. So you need to make use of this following concept. Elements in the same group has the same number of valence electron. Being a group 7 element, it will have 7 valence electron. Go ahead and try this practice. Pause here and play once again. You are ready to check your answer. I will now review the answer to this question. So, bromine is a non-metal. Non-metal give covalent join. So being a group 7 element, it has valence electron of 7. You only need this information. So if it needs 1 electron to reach octet configuration, it will share 1 electron. Same for the other atom of bromine. Drawing 2 circles symmetrically of the same size, since they are the same atom, and fill up 1 pair of electrons because each bromine share 1 electron. Then 7 electrons, 1 is being used. This leaves us with 6 valence electrons to be filled in. And then don't forget the legend. Now, if you cover one of the atom, you should be able to check that there is a total of 8 electrons for each bromine. This gives the octet configuration. Cover the other side too and check. Next question. Draw a dot and cross diagram to show the electronic structure of oxygen with a formula of O2. show only the valence electrons. Now, pause and practice. Then play again. Now it's time for the answer. If this is an examination question, check. If they are both non-metals atoms, they are covalent. I'm writing out the electronic configuration for oxygen atom as well as the working that I have shown so far. If you need 2 electrons, it will share 2 electrons. Again, symmetrically draw the 2 atoms with some space of overlap. There is 2 pairs of electrons that share because each oxygen atom share 2 electrons. So there is 2 pairs, cross and dot. These leave 4 electrons that are unshared to be drawn outside of the overlap region. Don't forget the legend. The legend is important to help you realize any mistake when you check your answer. Cover one atom. Check the number of electrons in the unshared and the shared area. You should get a total of 8 electrons, which give you the octet configuration that is stable, noble gas configuration. For this next practice, draw a dot and cross diagram to show the electronic structure of nitrogen N2. Show only the valence electrons. Pause now, try, and play later. Now let's look at the answer. Once again, check that the atoms in these molecules are non-metals, which give you a covalent drawing. From the periodic table, look at the proton number, which give you the electronic configuration of 2,5, and the working that each nitrogen atom need 3 electrons to reach 8 electrons in the outermost shell, so it will share 3 electrons. This will leave you with 5 minus 3 electrons, which give 2 electrons in the unshared shell. 2 atoms symmetrically drawn. Label the symbol N. There's 3 pairs of electrons in the middle because each nitrogen share 1 electron. Draw in the leftover 2 electrons for each nitrogen atom. Then cover up each of the atom to count 2 electrons unshared and 6 shared electrons. This makes it total of 8 electrons, which is octet configuration. Do the same for the next side. 6 electrons that are shared plus 2 electrons that are unshared, total of 8 electrons. This is an octet configuration, which is stable noble gas configuration. Now, draw carbon dioxide. Pause the video here and play later. Let's look at the answer now. Carbon is a non-metal and oxygen is a non-metal. Sharing between non-metals is covalent bonding. Write out the electronic configuration as part of your working. Write out that you need 4 electrons for carbon, so it will share 4 electrons. After the sharing, there will be no electron left that is unshared. Same for oxygen atom, a configuration of 2 states. You need 2 electrons, hence it will share 2 electrons. Left 6 minus 2, 4 electrons after sharing. These are the unshared electrons. Now, because there is 3 atoms here, the least number of atoms in the middle to be drawn. Follow the same symmetrical drawing. So I will draw 3 similar size because carbon and oxygen has 2 electron shell, so they have the same size. Oxygen will share 2 electrons, so we will share 2 electrons with carbon. Same for the other atom of oxygen, share 2 pairs of electrons. Now these are for oxygen atom. After you have drawn in, now if you check C, which is carbon, there's a total of 4 pairs of electrons, 2 on each side. Drawing the remaining electrons that are not shared. And write the legend. Cover up one side. 4 electrons unshared plus 4 shared electrons give a total of 8 electrons. Cover up the other carbon and oxygen atom. 4 shared electrons and 4 unshared electrons give a total of 8 electrons. Four electrons here and 4 electrons shared here, total of 8 electrons. Now draw dot and cross diagram to show carbon disulfide CS2. Sulfur is in the same group as oxygen, so this drawing will be similar to the previous drawing. Pause, play, once you are ready. Now let's look at the answer. By now, always check the formula for whether there is atoms that are non-metals or metals. So non-metal will give covalent bonding. Same thing, write out the electronic configuration, need how many electrons, share how many electrons, and left with how many electrons after the sharing. The workings are always the same. Notice that 6 electrons in the outermost shell for sulfur 2. 3 atoms. Sulfur should be slightly bigger. My bad for not illustrating this in the drawing. Because sulfur has 3 electron shell, it should be bigger than carbon. Now drawing the 2 pairs of electrons in the shared region, this gives carbon 4 pairs of electrons by now, and the 4 electrons that are unshared for each sulfur. Write in the legend as normal. Now, sulfur and oxygen, they are in the same group. And the group is group 6. So they have similar dot and cross diagram. There's 2 pairs of sharing between carbon and sulfur. There's 2 pairs of sharing between carbon and oxygen. The only difference that is not illustrated here is that sulfur should be drawn bigger than oxygen atom. Okay, drawing for water, H2O. Pause, try out, and play when you're ready. We shall now look at the answer. Both hydrogen and oxygen are non-metals and they will give a covalent drawing for dot and cross. Drawing the electronic configuration for hydrogen. Need how many electrons, share how many electrons, and left how many electrons. And oxygen need 2 electrons, share 2 electrons, left with 6 minus 2, 4 electrons after the sharing. Oxygen has 2 shells, so it's much bigger than hydrogen, which only has 1 shell. So hydrogen will share 1 pair of electrons with oxygen. Same for the other hydrogen atom. Draw in 4 unshared electrons for oxygen. And write in your legend so that you know the crosses are for oxygen atom electrons, and also the dots are for electrons of hydrogen. Now another similar drawing for dot and cross diagram for H2S, because sulfur and oxygen are in the same group. Pause, play, and check. Check that hydrogen and sulfur, they are both non-metals and they should give you a covalent dot and cross diagram. So hydrogen has an electronic configuration of 1. You'll need 1 electron, share 1 electron, and left with none that is unshared. Sulfur has 16 electrons, so 286 for the electronic configuration. It needs 2 electrons to reach 8 electrons in the octet configuration, so it will share 2 electrons and 4 electrons will be left. Likewise, draw symmetrically and share electrons to be filled up, 1 pair for each hydrogen, which give 2 pairs in total for sulfur. Now, because I'm using cross for electrons of sulfur, I will use 4 cross to represent the remaining 4 electrons that are unshared. Now, if you look at the comparison, oxygen and sulfur, they are in the same group, group 6. So they have same valence electrons. So you can see that these two drawings, H2O and H2S, they are quite similar. Now note that sulfur has 3 shells. Like what I have said earlier, it should be bigger than the oxygen atom, although I did not illustrate it in this drawing. For the second last practice, we will practice on methane, CH4. Pause, try it out, and play again once you are ready to check your answer. Now, let's look at the answer now. Okay, both carbon and hydrogen, they are non-metals, so they form covalent bonds. Carbon has 6 electrons, so configuration of 2, 4. So it will need 4 electrons, so it will share 4 electrons, and there will be no unshared electrons. Hydrogen has electronic configuration of 1, need 1 electron, share 1 electron, and again no unshared electrons. So there's a total of 4 hydrogen atoms, all symmetrically drawn to carbon. So carbon is in the middle and 4 hydrogen in the direction of north, south, east, west. So label all the atoms, draw in all the shared electrons for hydrogen first. So each hydrogen has 1 electrons that is shared. So it will share 1 pair of electrons with carbon. Now, if you cover up, hydrogen only have 1 electron shell. So the maximum in the first shell is 2 electrons. So now this is in noble gas stable configuration. We call it a duplex configuration. Okay, I cover just 1 more hydrogen to check. It is the same, 2 electrons in the outermost shell. So cover up all the hydrogen to see only the carbon. You have 2 electrons on each side, so a total of 8 electrons, which is the octet configuration. It is also known as the stable noble gas configuration. Then put it in your legend. Now for the final drawing, it will be CCl4, also known as tetrachloromethane. It has the skeleton of a methane structure, but with all the hydrogen atoms replaced with chlorine atoms. Now, pause and try, and play once you want to see the answers. We shall now look at the answer. Okay, look at the formula. They are all non-metals, so they are covalent. Carbon electronic configuration of 2, 4, need 4 electrons, so share 4 electrons, left with no electrons unshared. Chlorine has electronic configuration of 2, 8, 7, need 1 electrons, share 1 electrons, so left with 7 minus 1, 6 electrons. There is total of 4 atoms of chlorine. So I will draw chlorine slightly bigger than carbon because chlorine has 3 electron shells. And still try to make sure that the chlorine atoms do not overlap. And then label all the different atoms with their chemical symbol. Draw in the shared electrons. For each chlorine, 1 pair. This makes carbon having 4 pairs of shared electrons. Then 6 electrons for each of the chlorine that is unshared. So putting the legend, cover up, there is total of 6 plus 2 electrons 8 electrons for each of the chlorine atom. For carbon, there's 2 electrons times 4, total of 8 electrons, which again, I have to emphasize that this is an octet configuration, which is stable noble gas configuration. Now, side by side, compare CH4 and CCl4. Hydrogen only has one shell, so there is no unshared electrons outside of hydrogen. Chlorine has 3 shells, so it's bigger, but hydrogen is smaller. As I mentioned, hydrogen only have one valence, and they are all used in the sharing with carbon. Chlorine has 7 valence electron, only 1 is used for sharing. The rest of the 6 needs to be illustrated outside as unshared electrons.